Welcome back to Ox Tools. I'm Tom. So this is the next installment of Project Egress for my channel. I have quite a bit more video left. I took a little break in there. The last video didn't get a lot of views, so come on guys, get with the program, get some views on those things. What we got today is a cool little knob that's part of the assembly, and I'll show you where it fits in the assembly. It's made out of plastic. It's a pretty quick part. But it's got some kind of interesting geometry on it and sequence of operations to actually make it and measure it. So I had a little bit of trouble measuring it, but I figured out a way to measure it so it came out accurately. So let's check that out. Let's check out the drawings and then we'll get to the part. This is what we're doing today, is this little yellow gem here. And you know, once again, some of these parts on here are fairly distinctive in their look and their coloration, which was important to me to make come out correctly. So I got some, I found some yellow ABS rod on eBay, and I bought a foot of it for, I don't know, 15 bucks or whatever it was. And this stuff machines like cream cheese, and it's going to make a perfect little knob, little pull knob there. And I think I explained this before. You pull in this knob, it retracts a pin and allows you to fold this handle up. Now let's take a look. This is the tool actually that I'll show how we grind this tool and lay it out and all that in the video. Now I actually have, this is pretty cool. This is an actual assembly drawing from the Apollo program. And this was done by North American Aviation, Rockwell, and this is actually the assembly drawing for this vent valve. And there's our little knobicus there, and it varies a fair amount from the drawings that I got from the Egress folks. Okay, clearly there's a lot more going on in here than what was given to us. So we have kind of I would call it a slightly simplified version of the vent valve assembly, okay? But these are pretty cool. These are all done by hand. These were J-size drawings, which are just absolutely massive. And this is the good old days when people had to hand letter all this stuff and draw on the board with a drafting machine. And it's full of details, right? The positioning of this open labeling here, you know, the length of it, the size of it, where it should go. And there's more to this drawing, and this is just one little cut of a corner of it. But it talks about the kind of grease that goes into different areas in here, the specific torque for different fasteners, etc., things like that. Pretty cool history stuff there. And here's the knob that we're going to do out of yellow ABS, and there's a cross section of it. So it's a couple of interesting features on this. This little nose piece is tapered here with a radius in the corner. So I kind of want to work at it in the lathe, you know, from holding on this side and work from this direction. And the reason is it's got this conic shape in here, and I won't be able to hold it very easily afterwards. So if I do it all kind of as one piece, and then part it off kind of as the last thing, then it's all, it's pretty much complete at that point, and then I just do the mill work. So we need a tool bit to fit that. What is it? So it's 5 degrees with a 0.79 radius in the corner here, right? So we're gonna come in like that, and so this tool will have an angle on the nose like that blends into a radius with some clearance, and then if we're ambitious, I suppose I could get that little corner radius in there too. I think I'll do that as a second op. I'll just part off partially and then blend that corner and then knock it all the way off. So we're gonna go grind a tool bit here, and I put a little dicom on the top here just to make it easier to scribe some lines on here so I can get reasonably close. All right, got my little short-legged protractor here. Complements, this is an idea from Adam Booth, A-Bomb.
He showed one of these many years ago now. And I'm probably blocking the camera, but that's just too bad right now. Okay, so we get a nice line there. You know, for checking angles on tool bits, and these normally come with like a 6-inch leg on them, but just chopped it off and made it much more convenient for working on small stuff. All right, and then we got a 5/64 radius gauge here that I'm just going to kind of put tangent and tangent. And once again, this is just so I can get kind of close. And then I'll check it. Okay, that's probably all I need to get going on that. And then we'll grind that and see if it cuts ABS. Close. To 433. This thing's smaller than. So I'm just defining the edge, the end point. So that just gives me a shoulder to look at when when I'm doing my thing. Okay, we're gonna set this one the same way, but using a straight edge across the end of the part. This is actually pretty sensitive, believe it or not. Because you can slide and catch the tool. Okay, call that pretty good. And then we're going to go in 199. Yeah, okay. So, boy, that's a skinny little bugger, isn't it? Let's you know what? I'm going to run it at just a little slower, I think. You know what? What's it? I don't want it to chatter. If I can avoid it. There we go. That's the general idea. Can't see anything. All right, I think I got a good diameter calibration on this tool. It's a little tricky because you got a couple of tangent radii there and you're trying to pull a dimension off of that. But before I take it all the way down and this end gets really small here, not supportive, I'm going to cut this full radius on that little guy there. So what I'm going to do is I'm going to kind of put a center line on there. That way I can see when I'm coming up to the center line. And let's get this tool out of here. We'll come back to that one. Put our dually radius in here. All right. And very dang it. Chips is get pinched in there. I'm gonna get out of there. And I needed the clearance on the other side too for the tip of this tool. Keep my eye on that, make sure I got enough. No, that's okay, I can hit it now, it doesn't matter because I'm going considerably deeper. Right there. That's it. Stop. Stop while you're ahead. Okay. Well, it looks like I went ahead and did that angle. It wasn't very interesting, so. All right, let's go back to our other tool. See if we can give you guys a good shot of that. Okay, so I'm going down a ½ inch on that. Check it before I get too carried away here. So I'm measuring the tangent intersection right here. Boy, good thing I stopped, huh? All right, let's that's a tough spot to measure. Let's see where we are right in there. 390. Yeah, but we're still big in this area here. You know what? I need to what do I need to do? I don't know what I need to do. Keep going, right? Keep going. I wasn't happy with the way that measuring was going, so I backed up and rethought it. So what I did was I came in with a parting tool and just to find the final edge there where I can actually take a measurement at that point a little easier. So I recalibrated the tool. So hopefully this should have what I need, and then I can just take this down to the final diameter, part it off, and go from there. So, all right. So let's go back at it here. You look at my number, make sure I understand where I'm going here. 315. Yep. Okay. All right. Let's go. Plow on. When in doubt, plow on. Right. 40. That should be it. All right, then what we're going to do to verify that is stick stick our parting tool back in there. I know where that belongs. That belongs at, what, 047, right? Right there. Let's kiss that. Yeah, it's, you know, angular stuff is, can be kind of tricky to, oh yeah, all right, that worked good. So here I can get right close to the edge and verify. Yeah, I'm happy. Okay. Phew. Yeah, I think what I'll do is I'm gonna part way through that and then try to hit that radius. Hit that little radius on there before it falls off. And you know what? I'm going for it. I don't know, it's still got some structure there. I'll do a little more. A little more after that we get it off of here. Oh, that was pretty close. So this is bronze wool here. It's non-abrasive. I mean, it abrades, but it doesn't have any you know, hard abrasives in it. It actually works good on soft plastics like this to shine them up and do that final deburring. As where, you know, some sharp abrasives don't actually polish and deburr. Pretty good. There it is. All right, I'm pretty happy with that. We just got to poke a hole through the side of it now. All right, so we're going to drill a little pinhole through there. Last little nervous bit here before we. So what I'm going to do is I'm going to use the centering function on the DRO here. I'm going to pick up the pin close to where I want to do the deed. Okay. Now 0. Come over here. Let me do that again. Okay. And then I'm going to use the split function, or the center line function. Come back to 0. Like that. Now I'm going to make sure I don't do something stupid here. Okay, I come off of that a little bit. And then I'm going to pick up the edge of the plastic. Okay. Okay. Now I got a good pickup. I'm going to use I'm going to choke up on a short little, let's see, what's my number? 91. Okay. Let's, bozo, bump the table. So I'm starting on an angled surface there, right? But it's plastic, so I'm not super worried about it. So actually, you know what? Yeah, let's You know what, let's just keep going with this.
I was gonna change the shot, but
You know what, I don't know what the tip diameter of that is. Can I go down until it starts to? Oh yeah, it's only 40. It's only a little over a millimeter, so I can go down until I get a little countersink going. Like that. All right, let the games begin. 1/16 millimeter and a half drill here. All right. Actually, you know what? I'm going to get a nice tight close-up of that. All right, if we're ready. Nice. That's a classic, is to bang the chuck jaws into the into your fussy little part that you just did. Pretty happy. See if Senior Dell pin goes in there. Yep. Flash above.